Thank you. Mr. John.
Right, good afternoon, everyone. As it has been stated, my name is John Wejin. I'm an FEDGEN intern with Capit Case, and I'm going to make a presentation on a topic titled Setting Up JupyterHub on FEDGEN Private Cloud for Collaborative AI Programming. And I would like to really thank the leaders in the centers for giving me this opportunity to share a little out of what I've learned. So this would be the guideline for the first phase of the presentation. We'll look at relative background, and we'll look at the differences between Jupyter Notebook and JupyterHub. We'll look at the installation process, then a little demo, then we have questions and answers. What I really picked from the presentation of Professor Colin is that science has really shifted from a single approach to a collaborative and scalable in nature, in the sense that whereby one person sits only here to do research and then shares his idea with the entire world. That's a collaborative approach to science, and scalable in nature in the sense that we want our research to be really global. And also in pursuit of SDG goals, in achieving equal and quality education, that is the SDG goal number 4, open source science has become really vital tool in achieving this. Because if we don't have open science, the knowledge that we have would be restricted to a particular region. But with open science, we can be able to share knowledge and collaborate together. So for open science to be possible, there are needs. We need computational resources. We need platforms for coding. We need channel of communication for our work done. We need tools. We need the work we are doing needs to be replicated, and then access to these researches online and globally have to be easy and on a very large scale. So that brought about different platforms or ecosystems of tools. We can see we have Pandas, we have Jupyter, we have Julia, we have R and TensorFlow. So these are really bedrock or materials or raw materials for open science approach to research. Now, but the question is, if we have all these resources, how can we use those tools? How can we integrate different languages? You know, earlier on, if you are programming, you only program in Jupyter, let's say in Python, or you program in R. But we are looking at an approach whereby you can have a single platform that can give you the ability to program in different languages. And also, those platforms should be accessible to all. And that's what brought about Jupyter. So what's Jupyter Notebook and what's JupyterHub? So JupyterHub is a multi-user web accessible tool for running Jupyter Notebook. So it's like a server that makes available or that spins various or multiple Jupyter notebooks to clients so that they can be able to run their research and make maximal use of resources. So Jupyter Notebook is an interactive web application that enables the editing and running of documents using a browser. So if you are running Anaconda and you launch Jupyter Notebook, it normally uses your browser to present the platform. So that's what it meant by saying Jupyter Notebook is a platform or an application that enables the editing and running of documents using browsers. So there are steps in installing Jupyter Notebook, but we need to have some things in place. Like we need to be familiar with command line. We need to have a server. For now, Jupyter Notebook runs on Linux. So, but I think there is a way around trying to see how you can run it on Windows. If you have a Linux application on it, maybe WSL, you can be able to run it on Windows. Then you also need a reachable IP address, because the essence is that let's take for instance, you're a lecturer and you want your students to keep coding even while they're at home. So you need a reachable IP address, that is a public IP address that your students can be able to use. And if you have the IP address, you can be able to also use a DNS to translate it so that it can be accessible to them anywhere and globally in the world. And then ensure that your server has Python 3, Python 3D call, and it's packages that you really need to have on your system. So I will go to the next step. So if you have your system and your server is public and the IP address is public, you can directly open your terminal and type sudo apt install Python 3, Python 3 div, git and coil to be able to install those things. Then you type the command coil-l. There are two versions of Jupyter. You have the JupyterHub or the Littlest JupyterHub. So we are using Littlest JupyterHub. It's more lighter and more accessible. So once you type that command on your terminal, you click enter. So it will run and install or bootstrap, set up JupyterHub on your server. And so because you need an admin user that will be able to set up the entire JupyterHub server interface, you need to put a username on this command coil-l-https, where you can see admin-user-name, you replace it with your own chosen username. So once that is done, you copy the IP address of your server and you put it on your browser and access it. So if your installation is really successful, this is what you will have as a display once you enter the public IP of your server. So if you see this sign, that means you have a successful installed JupyterHub on your server. So you log in with your username, the username you created during installation, and you choose a password. And the password should not be less than 8. So once you have that, you can now log in into your JupyterHub to configure. So I'm going to stop sharing and share my own. So I've already spined a VM on our HPC cluster. In FEDGEN we have HPC cluster. We also have a cloud testbed. So I've already spined a VM. So I'm trying to access my VM now. All right, because I have limited time, I think they've shared the participants all have user login to their JupyterHub account, so they can easily log in. So you type Jupyter nb-gpu.fedgen.net on your browser. So can you please do that? On our browser, let's type Jupyter nb-fedgen, gpu-fedgen.net, sorry. I believe you can see my screen. So let's type this Jupyter nb-gpu.fedgen.net. So how many people have successfully logged in? You log in with your username that was given to you in your mail, and then you choose a password, not less than 8 for the password. So if you successfully logged in, you have this environment. And so there are two types of users on JupyterHub. We have the admin user and we have the normal users. So the normal users are, let's say, for example, the lecturer, your students. You make them as normal users, while you as the admin. So I've logged in as an admin. I'll show us how to add. Okay, so you go to File, then you go to Control, Hub Control Panel, and click on Hub Control Panel. Then you go to Admin. That's if you are logged in as an admin. So from here, you can see Add Users. As an admin, click on Add Users. So once you type, let's say, for example, let me create a user. Let's say academy.m. So if you really want to make this user an admin, you click on the box admin and add it. So he automatically becomes an admin. But if you don't want him to be an admin, you just directly add him as admin. So, and from here, you can be able to see those that are logged in, and you can see for how long they've logged in. So as an admin, you can be able to stop the user, and you can also be able to start a user's server. So for normal coding, you click on the Python environment. And on this Python environment, this is your Jupyter notebook. So we can see why I said a JupyterHub is a multi-user environment for running Jupyter notebook. So you can see that I'm in my own Jupyter notebook. And from here, I can be able to code. So I can be able to run my code from this platform. Also, you can be able to upload your files. Let's say maybe you have a local file for Jupyter or notebook file. You can be able to upload it using this upload option. You can also be able to create a folder or launch another platform. So you can be able to create a folder from here, and let's say maybe data set. So, and from this data set, you can be able to upload your data set or your files from there. And you also have an option for terminal, where you can be able to either install or update certain packages on your terminal. So this is the essence of the terminal on the Jupyter notebook. So as a normal Jupyter, you can be able to set up how your Jupyter Notebook should appear. You can be able to edit and make some settings from here. You can also be able to make some interfaces or enable some interfaces or change modes from here also. So I think this is just a little on the Jupyter Hub and Jupyter Notebook platform. So I don't know if there is a question before I move forward. Any questions from our physical participants and online participants?
Okay. From my hand, Engineer Wejin.
Yes, sir.
Well done. Does it mean if I want to install a JupyterHub on my standalone system, I'm going to follow the same procedure? That's the first question.
Okay.
The second question from my hand is, I was seeing how after you logged into the GPU server, the Jupyter Hub on the GPU server, I was seeing R icon on the launcher window. So does it mean I can also, while I'm running my Python code, I can also run R code? And what are the other languages? I'm asking this question so that you can elaborate for online participants to also maybe know the full capabilities of the Jupyter Hub. So what are the other languages that are supported on the Jupyter Hub, which will allow me to do multi-language coding? That was part of your presentation. Thank you.
Okay, sir. Yes, you can install Jupyter Notebook on your own lab standalone system. But you have to make sure that we've stated earlier on there are some requirements. You are familiar with command line, and also it's a Linux operating system. It's more advisable for Linux operating system. So it's very possible for you to install it on your own personal or standalone system. Then for the launcher, for the R canal, yes, you can be able to add different canals on your Jupyter Hub. Because as we stated earlier on, we have different programming languages, and the essence of collaboration is that you'll be able to run different programming language on a single interface. That's what the Jupyter Hub is meant for. So it's very possible for you to have different languages. You can also have Julia on it.
Okay, thank you.
All right. So any question again from the online participants or physical participants? There are no questions. Let me share my slide.
Ashuza is raising his hand.
All right, Ashuza, you can exactly unmute and ask your question.
Yes, thank you for the floor. So I want to ask a question on the Linux terminal. Yes, the one just we can see when we are connecting to the Jupyter. So if we look on the welcome scripts, we can see that we have the name of the user, it's FEDGEN GPU. So I want to ask, is it that every user has its own kernel that is running, like part of the main OS, or we are sharing the same kernel? So because, for example, I'm running an app on the kernel, if the kernel was common, that's the first, maybe the first hypothesis. So, and my program is crashing. So if you are sharing the kernel, can make that other programs that are running also can run into the crash. But if you are separating the kernels, it makes like my program can crash and other program will not crash. So I want to know what is the architecture of that kernel. Is there a shared one, or is a kernel like the separated?
All right.
Thank
you. The kernels are peculiar or separated as it is. Because if you are running your own Jupyter notebook and anything happens on your own Jupyter notebook interface, it doesn't affect the other person. So the JupyterHub server spins a separate notebook interface for each client. So whatever a client is doing on his own platform does not affect the other client. It's only peculiar to your own notebook.
Okay, thank you very much.
So let's go into version control with Git and GitHub. So this would be the outside that will guide us through.
There's another hand that is up. Engineer Emmanuel. Hello, John.
Engineer Emmanuel, please can you
In fact, we have two hands that are up.
Okay, thank you very much. Can you hear me, please?
Yes.
Okay, the Jupyter notebook that I spin on my user, I noticed that you also say I can create folders and put files in it. Is there a limitation to the size of that Jupyter notebook?
Okay, yes, there is a size, there is a limit to size, but that limit is being set by the admin. So the admin can be able to set size for data that is uploaded on the JupyterHub. And he can also set the capacity of RAM to a particular user. So it's very, very possible.
Okay,
because the essence of the JupyterHub is to share resources. Let's say I have a server that is, let's say 100 terabytes, and it's just me, I'm using it, only me. I'm wasting the capacity. But since we are looking at collaborative research, and that is what we are also doing in Copy Case and FEDGEN, we'll be able to see that we make maximum use of resources, even in our own research endeavors. So it's very, very possible. The limits can be set by the admin. Thank you. All right, so as earlier stated, our research is collaborative rather than being single. And in modern day, you have software development or research in the team, while different persons are given a task towards achieving a goal. So we need what is called version control. So let's take, for example, in software development, you normally hear people tell you, this software is version 1, this software is version 2, this software is version 3. So that has been made possible using version control. So version control is a method of modification or computer codes and other collection of information. So let's say maybe you've developed software that does, let's say, check where students come from, or like their institution. And now you want to add another feature to that software. Once you add that feature, you can decide to say it is an upgrade on the earlier feature. So that earlier feature is taken as version 1. And then the added capability in version 2 is that You can not only know where the student is coming from, but you can also know which continent or which country is coming from. That's version 2. So that's the essence of version control. It helps us manage our softwares and our research in phases and even as we make release of our softwares. Then the modifications are usually known as versions, as I earlier said. But those modifications are what we refer to as versions. Now, why do we need version control? Teamwork becomes easier. So let's say, for example, in web development, you have someone that is working on the front end, you have someone that is working on the back end, and all of you are not in the same place. So that person can be able to code from his own end and update the entire software, while the front-end developer also does his own work and also update it on the same platform. It also helps for proper documentation. You who made the change, who made an update. So it also helps for backup. So you can be able to work locally as you are developing and also upload it online. So if anything happens to your software or your code, you still have a backup. So let's say someone that worked on a back end has that back end code on his local machine. And as someone is also working on it, he ended up changing, let's say, a particular feature on that back end that disturbed the entire back end. You can be able to fall back on another person's copy of that same back end. So it helps in doing that, and it also helps us in analysis. So there are different version control system tools. Some of them are, as we can see, we have Git, we have GitHub, we have CVS, we have Bitbucket, and Mercurial. But we know that the common one or the most popular one is GitHub. And that's what we are looking at now. So Git is a distributed, non-linear version control system tool for developing software in a collaborative approach. That's simply what Git is. So what are the features of Git? As we said earlier on, it is distributed in the sense that people can work in a collaborative approach from wherever they are. It is also compatible in other sense. In other sense, it's compatible with almost the most, or let me say, the top 3 operating systems: Mac, Linux, and Windows. So it's also non-linear, as said earlier on. It has branching. So what branching means is that if you have a main, because as we can see earlier on, we have what we refer to as a master branch, and we also have what we refer to as a feature branch. So if you have a master branch where you post the whole change of your code, you can be able to create a branch of that same code. So if you make changes on the branch code, you later upload it, or what we call push it to the main repository, so that people will be able to access it. So, and the reason for having branching is that it enables you to first check how your code will behave before publishing it or making it open to other developers. And it's also lightweight, it is fast, it is open source, that means it's free, it's reliable, and it's secure. As we can see earlier on, later on, you can be able to use SSH keys to be able to protect your own repositories. And it's also economical, it's free, you don't need to buy. Though now on GitHub there is enterprise So there are common GitHub commands. We have what we refer to as git init or initiate. So if you create a repository locally and you want to make it public, you have to initiate it from your own local machine before you can upload it online. We can also have git add, we can have git push, we can have git pull. These are terminologies will be clear as we go into the demonstration part. So we need to understand basic terms. What's a directory? A directory is just a folder. What's a repository? A repository is just like a folder that contains your whole project. CLI, that is command line. CD, that is change directory. Code editor, you can have different types of code editor as a programmer. Anyone you can use that is suitable for you. Then you have GitHub. Now GitHub is like a web-based repository for your project. So Git and GitHub work hand in hand. And then there's what we call clone. So it gives you the opportunity to be able to get a repository on your local machine. So that's what cloning is all about. To be able to have a repository, complete repository on your own local machine. So let's go into small hands-on here. So there are two perspectives to Git and GitHub version control. You need first to have Git on your own local machine. So that means you can go to the GitHub website and install Git on your local machine. Then you also need to create a GitHub account online, which is free. You can go to the GitHub website and create an account using your email. This is a Git bash interface. So after installing Git on your local machine, you'll be able to have this interface. Then you run it. So as I said, Git is like Linux. As you can see, I have these folders on my system. So I have a system that a folder that I've already created. So I will cd, I don't know if you can, okay. I will go into my directory. Let me look for, so as you can see, I'm in this directory. So what's happening now here is I have an account on GitHub that I've already created a repository. So now this is the repository on my own local machine now. So how did I get that? I cloned my local repository my GitHub repository on my local machine. And I'm now in it. So I will start looking at some commands like git status. It's a command that tells you what is in your own repository and also what you've done the last thing. You can see here and I said on branch main. That means now I'm on the main branch. Now this symbol depends on the type of your machine or your OS. Some you might have master. Main stands for master. So if I have another branch, or if I create a branch, I can change my directory to the branch on my repository. So I have to add it. So I need to pass this command git add my file name. So if you have created multiple files, you can use the dot command to add them, all of them. But if you are looking at a particular file, you have to type the file name. So FEDGEN.txt. So I've added that. If I now do git status, you now see I have a file. So that means this file is now seen in my own directory. So, but for me to be able to upload it or push it to my GitHub account, I need to commit, what we call commit. So you type git commit, then you have -m. This -m means message. Because we said Git is very good for collaborative work. So you want to give a message so that once your other partners view your repository, they'll be able to know what you have. So it's how you pass a message. Let's say FEDGEN. So you can see now it's showing that one file has been changed. So if I now want to push my document to my GitHub account, I will now type the command git push, then what we call the origin, that specifying either it is a main repository, main branch, or it's a future branch or any branch that I've created. So since here I only have a main branch, I'll type main and click enter. So we can see now from this output, it's saying the result, I have pushed a document, and this document has been pushed to my GitHub account. You can see the link to my GitHub account. So now if I'm going to stop sharing this interface and share my own GitHub. So I'll log into my own GitHub account. So from here, you can see that actually it has been uploaded or pushed to my GitHub account. That is why you can see that it has been pushed to this account. And if I do git status, you can see that it's saying that there's nothing done because I've already updated or uploaded the file I have created. I think I'll stop here a little bit.
Thank you so much, Mr. John Wejin. Thank you very much. So if we have questions, we can put them on the chat box and then you'll attend to them while we move very quickly to the next session that we have right now. Because of our time, that's why we're doing that. So please, if you have questions, put them on the chat box. He can respond quickly to those questions while Mrs. Priscilla Jai,